Problem 546. Find the acceleration of the 5 kilogram block in the figure below. I have a 5 kilogram block which I'm going to initially call big M on the right. On the left I have a 4 kilogram block which I'm going to label little m, and then I've got a block in the middle, little m1, which is 2 kilograms. Throughout this calculation I'm going to assume g equals 10 meters per second just to simplify numbers. So the first thing to do is to argue which way the block is going to move, this m1 block. Just conceptually I'm going to put my finger on this and hold it stable, and in that case nothing is accelerating, and that means the upward tension on this cable has to be 50 newtons to hold this 50 newton weight, and the upward tension on the left side has to be 40 newtons to hold this 40 newton weight, and then that 40 newton tension is going to be acting in this direction, and the 50 newton tension is going to be acting in the other direction. So if I let go with my finger, there would instantaneously be a 10 newton imbalance between right and left, right being 10 newtons bigger than the left tension, and the maximum force supplied by static friction is going to be the 20 newton weight from this m1 times 0.1, which is 2 newtons. And since the tension imbalance is greater than the static frictional force, the acceleration is going to be to the right for block m1. So moving over to the free body diagram with that in mind, I'm going to start with little m, label the upward direction as the positive direction, parallel to the acceleration that I expect, and there will be two forces acting on little m, tension T1 up and an mg down. I'm expecting the T1 will be bigger than mg to lead to an acceleration in this direction. Over on the right side, I expect big mg to be bigger than T2, and now I'm going to reverse my sense. So the positive direction is again parallel to the acceleration, which on the right side is down, on the left side is up. So I'm expecting mg to be big mg bigger than T2, so I get a net acceleration. And then on m1, the mass on the table, T2 is going to be bigger than T1. Since the motion is to the right, the kinetic frictional force is going to be to the left. Now I can use this to free body diagram to write down my Newton number 2 equations. Okay, so I have 3 equations here plus my friction equation. So my Newton number 2 in the vertical y direction for little m is T1 minus little mg equals ma. For the little m1 mass, it's T2 minus T1 minus the kinetic friction is equal to m1a. For the big M, it's mg minus T2 equals big ma, and then I have my friction equation, which, as we mentioned, the kinetic frictional force is going to be 2 newtons, and it's going to be acting to oppose the acceleration and the motion to the right. So I can now put some numbers in equations 1, 2, and 3. That's off on the left here. So that would be T1 minus 40 newtons. That's what mg becomes with 4 kilograms, and g equals 10 meters per second equals 4a. For little m1, T2 minus T1 minus 2, that's the frictional force there that we computed down below here, is equal to 2a. And then equation 3 becomes 15 minus T2 is equal to 5a. So my approach here is to use the second equation, this one right here, and to plug in values from equation 1 for T1 and from equation 3 for T2. So doing that, T2 becomes 15 minus 5a from this equation, minus T1 becomes 4a plus 40 from this equation, minus 2 is equal to 2a. And so 50 minus 40 is 10, minus 2 is 8 newtons, and minus 5a minus 4a is minus 9a, and putting that over on the other side of the equation, plus 9a plus 2a is 11a, so a is 8 over 11, which in other words is 0.73 meters per second per second. And that's what the problem asks. I go a little bit further here, and I show that T1 from equation 1, now we can get an expression value for T1 is 4a plus 40, and so that's 42.9 newtons for the tension on the left side. And T2, using equation 3, is going to be 50 minus 5 times 8 over 11. That's A here, which is 46.4. So you note that T2 is bigger than T1, as expected, and that T2 minus T1, the difference between these two, is 3.5 newtons, and that imbalance is greater than 2 newtons, which of course is how we argued the direction of acceleration for the system.